Hello there guys and welcome back. This is Science Also. Let's drop in some physics in this video. Do you know how the DC motor works in your toy car? Okay, I hope you don't have a toy car but you have seen DC motors. Let's combine the knowledge on circuits and knowledge on magnets to understand how the DC motor works. Let's take some wires, battery and a light bulb and connect them. Electricity is flowing through the wire and this is called conventional flow. If we flip the battery, then the current will flow in the other direction. The light bulb will work no matter what direction the current flows. There are some devices which will work differently depending on the direction of the current flow. That's the basics of circuits. This is a magnet. It likes to attract other metals, like these needles. If we bring two magnets together, opposite poles attract, similar poles repel. Magnets may have various shapes: horseshoe magnet, ring magnet, bar magnet and many shapes. The magnetic power of magnets are always on. You cannot turn it off. That's why these type of magnets are called permanent magnets. Let's make a hole in the center of the magnet and insert some tube so that it could rotate around its axis. If we bring closer another magnet, our spinning magnet will immediately line up with the stationary magnet. If we switch sides, opposite poles attract, similar poles repel. If we keep doing it, the magnet will rotate 180 degrees every time we do it. Let's keep this aside for now. This is a metal bolt. This is not a magnet. It's made up of magnetic domains but they are lined up in different directions, which means there is no magnetic power. Now let's take a wire and wrap it around several times and create a circuit. Okay, the current through the wires forces the magnet's domain to line up. That means we created a magnet, more specifically an electromagnet. It can do everything a permanent magnet can do. It has north and south poles. It can attract metal pieces. But our electromagnet is something special. It can be turned on and off, just like the light bulb. Now observe what happens when we flip the battery. The direction of the current changes. This will cause the magnet to switch poles. North will become south and south will become north. We can flip the wires instead of flipping the battery to make it convenient. Let's come back to our spinning magnet. This time, instead of this permanent magnet, let's place the electromagnet. As soon as we connect the wires, the magnet will turn on and it lines up with the side magnet. Now if we switch the wires, the poles also will get switched. Same poles repel, opposite poles attract. Now if we keep doing this, our electromagnet will keep spinning. Let's bring another magnet on the side to make this more stronger. Notice that this is south and this is north. They work together to spin the one in middle. This is a very basic motor. We need some improvements. Instead of a bar magnet, let's place in more curved, stronger magnets. Instead of the metal bolt, we are going to use a metal loop. This is called armature. Connect the wires and we have a circuit again. This time you can imagine the electromagnet as flat like this, with south pole pointing up. Now the armature will spin until opposite poles line up. We can keep it spinning by switching the wires, just like we did before. But this is a lot of work to do manually. We need to add something called commutator. It is a ring with gaps on opposite sides. The commutator will spin along with the armature. Now we connect the circuit with the brushes on the side. These brushes will slide along when the commutator spins. Make sure you notice that this time the current flows in the other direction when the brushes make contact with the other part of the ring, which means the electromagnet switches poles. It will spin as long as it is connected to power. So far we have connected only one loop. But in real motors there are many lobes which increase the speed and power of the motor. Instead of thick single armatures, they use something like this. You might have seen the interior of a DC motor from a toy or drone or anything you have at your home. So this is how a DC motor operates. So I have a special question for you. Answer this in the comment section. What will happen when we send AC current instead of DC current to the motor? Thank you for watching. Hope you enjoyed the video and learned something new. Click on the subscribe button and press on the bell icon. See you guys soon in another interesting video. Until then, bye bye.